Hi, everyone. Thanks for joining. My name is Evan Singer. I'm the National Sales Manager with Vessel Packaging. Appreciate Andrew for inviting me to present today on canning quality. Vessel is North America's one-stop shop for can supply, and within Canada, we offer mobile canning as well. We supply printed cans, blank cans, and labeled cans across North America. Shipping from 3 locations within Canada on labeled cans, Vancouver, BC, Calgary, Alberta, and Mississauga, Ontario, and full truckload printed and blank cans from Crown, Cork, and Seal locations across North America. Over the next little bit, I'll be chatting about canning quality and quality in general, why it's important to have a quality program, and then what we call the 3 pillars of canning quality when it comes to beer: oxygen, micro, and seam control, and then how this all ties in for mobile canning or even canning in-house. So first off, why cans? That's Vessel's thing. That's what we do. But cans have definitely become the dominant vessel for packaged product across most beverages and especially in beer. As of 3 years ago, over 85% of national packaged beer sales were in can, and it's definitely grown since then. From a quality perspective, the can is a significantly superior vessel to a glass bottle when it comes to both light control and also oxygen control. There's much less, there's zero opportunity for light to enter a can, entirely opaque, and no opportunity for light struck defects. If you've ever had Heineken out of a can versus a bottle, you can tell pretty quickly that's the only difference, but a significant flavor change. And oxygen ingress is definitely reduced over time when it comes to a can seam compared to any sort of glass closure. From a sustainability perspective, aluminum is much easier to recycle than glass is. A much greater percentage of aluminum cans are recycled. And for shipping, the weight is significantly lower across the supply chain, so lower carbon footprint in that perspective. And then from a cost perspective, cans are typically more cost effective than glass packaging when it comes to the can itself, the closures, the landed cost when it comes to freight, all the secondary packaging, the filling and shipping costs. So all said and done, you can definitely find more margin when it comes to can product than product in glass. So when it comes to quality, quality is really just a different way of saying risk management. A quality program is in place to make sure that process failures are minimized, and more importantly, if there is a process failure, how you can control any product that's not up to standard from entering the market. Like any risk management program, there has to be an understanding of the tolerance to risk that's acceptable compared to how much you can spend on trying to control those risks. Quality assurance and quality control are two aspects of any quality program. Quality assurance is really focused on the processes that make sure that your quality standards are maintained. Whereas quality control is the inspection that goes into making sure that the quality assurance processes are tested. So when it comes to quality assurance would be what you're doing and why you're doing it to make sure that specs are met. And then quality control is making sure that regular tests are being done on those specifications. And when it comes to canning quality, really the 3 most important pillars are going to be oxygen control, making sure that as much oxygen is excluded from the filling process as possible. Microbiological control, making sure that the process is not introducing undesirable microbes to the finished product. And then seam control, making sure that the seams are formed properly and inspected properly to make sure that leaks or other issues due to seams don't occur. Why have a quality program? Quality an expense in any business, and it's one that's very difficult to measure the return on investment on. Quality is seen as a cost as opposed to an opportunity for gaining revenue, but the fact is that the risks of not having a quality program are pretty significant when it comes to cost perspective, and getting into things like a recall. So first off, making sure that you are measuring the things that you need to control. If you don't have an ability to measure oxygen, seam specifications, micro contamination, you can't control those things. So quality assurance is what's setting the standards for those quality parameters. And then your quality control program is defining how you measure those parameters, how often you're measuring them, and what to do when something goes out of specification. One of the most important things in a quality program is traceability. The last thing anyone wants is product going out onto the market that potentially has to be recalled, but having a good quality program will make sure that if there is a situation where there's a recall, you're minimizing the impact of that. Really important when you're date coding to do it down to the package level. It's not enough to code your 4-packs or 6-packs or even at the case level. Because even if the retailer is supposed to be selling them as a package, they may break it down into individual cans. Consumers may only have an individual can available when it comes to a complaint. So really important to make sure your cans themselves are coded. And when it comes to coding, depending on the system you have, you may be doing it manually at small scale or with an automated date coder at a larger scale, and just making sure that you get down to the smallest interval that's feasible, whether it's to the can itself, to the minute of production, or if the production is small enough to the day or even the shift. Making sure that quality control measures are taken into effect as often as possible will minimize the interval at which a potential recall would have to be instituted for. Depending on how much you think is an acceptable risk of a volume of product to get on the market that may have to be recalled, is how often you're going to set your measurements, right? From the last in-spec measurement to the first out-of-spec measurement, assuming your production stops with that first out-of-spec measurement, is the potential risk for any recall. So making sure those measurements are within a reasonable time frame based on how quickly your production goes. So why are we controlling for oxygen? Oxygen is probably the biggest dirty word when it comes to quality with respect to beer. Oxygen is what's going to determine the shelf life of your beer, from how fresh it is coming out of the brewery to when it's consumed. So oxygen can affect both malt and hops. Malt compounds will oxidize into a compound called trans-2-nonanol, which gives stable flavors. It can be paper or cardboard at the start and then go into caramel, and it will also darken the beer the more and longer oxidation takes place. On the hop side, you'll lose a lot of the desirable flavors and aromas of hops, especially aroma hops. But you can also generate unpleasant bitterness from the oxidation of certain hop compounds. With your entire brewing and packaging process, ideally, after fermentation, all the oxygen consumed should be gone. Your primary beer will have next to no oxygen, but there is lots of opportunity for oxygen to be picked up between fermentation and packaging. Anything where the beer is transferred or processed, additives, dry hopping, any transfers, any filtration, especially packaging, are going to be potential sources of oxygen pickup. Oxidation is accelerated by higher temperatures, so the colder the beer is stored, the slower oxidation will take place, regardless of how much oxygen is in the beer. So knowing what your supply chain is like, knowing that if you do have oxygen pickup, the beer should be stored as cold as possible is definitely going to help with oxidation and shelf life. So how do we control oxygen when it comes to packaging? So first off, we want to not expose the beer to any sort of oxygen, and making sure that we're removing oxygen from any vessel, any line where the beer is going to go through. So making sure that tanks where beer is being transferred to are purged with CO2. Any lines that beer is going to be transferred through are packed with deaerated or deoxygenated water. Cans themselves are purged with CO2, and then undercover gassing where CO2 is blown into the space between the can body and the end to eliminate picking up any oxygen in that part. We want to make sure oxygen is not introduced into the packaging process during packaging as well. One of the potential risks of transfers is having a gasket out of place, having a potential leak in the line where beer flow will actually create a Venturi effect and pull oxygen in. So you could have a situation where a line is loose, but instead of seeing a leak, you'll have beer coming in undetected. Making sure that the filling process itself is not introducing any oxygen. So first off, going into a can, the majority of breweries will be using a gravity filler as opposed to a counter pressure filler. So the beer is entering the can in a atmospheric environment, atmospheric pressure, ideally with as little as possible oxygen in place. That said, bringing the beer in a turbulent manner will definitely result in more pickup and more exposure to oxygen that's in the can in the atmosphere. So making sure that your tank head pressure, the speed of your fill, the position of the fill heads is adjusted to create laminar flow. Different fillers will be, behave differently. The Wild Goose fillers that we use actually have a timer on the fill heads to start lifting them up when the bottom of the fill head is under the fill level of the beer. So making sure that we're filling under the liquid level as opposed to coming in over the liquid level and then spraying in will minimize how much pickup there is with the filling process. The other large potential source of oxygen in a can is the headspace. Beer is not supposed to come up to the very brim of the can, and any of that headspace can be a source of oxygen. So making sure that we're capping on foam on beer, creating foam in that filling process to fully fill up and push out any oxygen from the headspace. Having a bubble breaker in place, bubbles on top of the foam can be a source of oxygen, and a bubble breaker will essentially break up those large bubbles and let any of that oxygen be released to atmosphere. And again, making sure that the transfers in the filler from the fill heads to the seamer are quick but gentle, where there's no risk of the can sitting exposed for a longer period of time, and there's no turbulence in that shaking of the can that can allow for oxygen to pick up. So how do we measure oxygen in beer in can? There's a tool that we use called a Gehaltometer. The brand that Vessel uses is a Hoffman's Pentair Gehaltometer, and it's a dissolved gas meter. So beer flows through the meter, and there's an optical sensor that can tell how much oxygen is present in that beer. It's important that it's a steady flow, that the temperature is not changing, because those will all affect measurements. But the sensor detects the presence of oxygen. Gehaltometers can also be multi-use, multi-gas, and be used to get levels of CO2 as well. And the Gehaltometer can be hooked up to really any vessel or tank where the beer is. So we'll use it to test the beer in tank, in line, and in package. In order to test in package, we'll use a can piercer. So the can piercer will push beer from the can into the Gehaltometer with CO2 pressure. It creates a sealed penetration in the can, making sure that there's no oxygen added to that measurement. So we'll measure in a number of places when it comes to mobile canning, and definitely something we recommend for breweries canning in-house as well. So we'll test the packaging tank, the tank where the beer is being packaged out of. And that's really to get a baseline of the oxygen level in that product. There isn't really a way to remove oxygen from beer through the filling process. So the DO level, the dissolved oxygen in the tank, is really the baseline for how much oxygen could potentially be in the can. And then anything above that is going to be pickup. We'll test the line immediately before beer enters the filler to see if the line is picking up any oxygen. Again, any loose fittings, any air pockets due to poor line setup could all be bringing in oxygen. So by testing at the filler, making sure that it's as close as possible to the DO level in the tank, we'll make sure that the line is not picking up any oxygen. We'll test that before we start filling cans, and then potentially as a troubleshooting measure in the case of any high oxygen levels in the cans. And then finally, in can, there's two measurements that we'll take. There's the dissolved oxygen, which will ideally just measure how much oxygen came in with the liquid in the fill process. And then there's the TPO, or total package oxygen, which measures not just the oxygen in the beer, but also what's in the headspace. We'll approximate a TPO using a shaken DO. So we'll have a set shaking and resting process to attempt to integrate any oxygen in the headspace into the liquid and then test there. Really important that oxygen measurements are taken as soon as possible after any process when it comes to tank transfers or the can filling process. Oxidation happens immediately. So testing, let's say, a day after a transfer, 2 days after a transfer, 2 days after filling, will give a much lower reading on how much oxygen is in that product because the oxygen has already started the oxidation process. So by measuring right away, you'll get a good and accurate measurement of how much oxygen is present relative to whether it's the baseline of the tank or DO versus TPO. So the next pillar in canning quality is microbiological control, microbial control. Microbe contamination is definitely a factor in shelf life. Beer is fairly stable when it comes to microactivity. Beer is pretty safe. The alcohol, the hop acids, the pH all protect beer from being contaminated by anything that could be a pathogen to humans. But that said, you can definitely get undesirable results when a beer is inoculated by certain microbes. There are microbes that can metabolize parts of beer to produce either atypical, undesirable flavors for the style. A Brett contamination in a beer that is not supposed to have Brett will totally change the flavor, and whether or not it's pleasant or unpleasant, it won't be what you intended to put out to market. There's also a concern with re-fermentation. So most beer is fermented down to essentially unfermentable sugars to brewer's yeast. However, there are definitely microbes that can ferment some sugars that are unfermentable by the yeast that you use to brew that beer. So if those microbes are inoculated after or before packaging rather, you could have a concern of re-fermentation in can, where additional CO2 is produced and could potentially lead to pressure building up in the can to the point where it could explode. Products that have added sugars, especially that aren't necessarily going to be shelf stable, are at even more risk for this. The best option for controlling micro, especially in beer, is making sure that you're controlling inoculation. So making sure that everything is clean and microbes are not being added. However, there are certain beverages that may not be as safe as beer that you're producing. Non-alcoholic products containing added sugars, products that are going to be on the shelf for an extended period of time that may require additional stabilization. And one of the most common processes for that is pasteurization. So pasteurization involves heating the beer in package or pre-packaged to a certain temperature for a certain period of time in order to kill a certain percentage of any of the microbes of concern. And these factors can all be calculated based on the level of risk, the potential micro load. There is definitely some engineering that goes into setting pasteurization processes. Pasteurization should, if done properly, should eliminate any live microbes from the product. However, there's definitely a risk of the pasteurization process affecting the taste of the beer. It can, you're cooking the beer past packaging, and heating it up like that will definitely accelerate oxidation. So there's definitely a bit of a risk reward when it comes to pasteurization. So how do we control micro? By making sure the beer is clean, by packaging clean beer. On the hot side of brewing, the kettle boil should kill anything that might have been present upstream of that. However, once the beer goes through your wort chiller, it is definitely vulnerable to micro contamination. So making sure everything on the cold side is sanitary, making sure any additions to the cold side are sanitary. Your yeast can be a major source of contamination. If you're serial repitching, there's risk that the yeast that was pitched to one beer will have been exposed to some kind of undesirable micro, and then repitched into a new beer and bring that with it. Any transfers, filtration, packaging processes can be sources of contamination. Really, anytime anything past the wort chiller is a risk for contamination, even the wort chiller itself. In order to minimize risk at the filler, the can filler will make sure that there's a proper CIP of everything from the tank through to the filled cans. Proper CIP is making sure that CIP is done in consideration with the equipment supplier, but also the chemical supplier's recommendations. And the chemical itself, certain fillers will work better with some chemicals than others. Certain fillers are totally incompatible with some cleaning chemicals. Anything with aluminum components should not be used with hot caustic or hot acid. The concentration of those chemicals, how much agitation there is. So what's the speed of flow? Are you able to create turbulent flow? Here's one case where turbulence is actually desirable because it will help with that agitation and improve the cleaning process. The time, how long you're circulating cleaning chemical for, and then the temperature of that chemical. Usually cleaning chemicals will be more effective at hotter temperatures. Avoiding risk of exposure. So many breweries will work with microbes that would be considered beer spoilers when it comes to clean beers. And there's a risk of that. There's a risk of sharing equipment and gaskets and tanks between clean beers and dirty or sour beers, so to speak. From a mobile canning perspective, Vessel does not package any wild and sour beers with live microbes because it is a risk that any clean beer producers will have to take that we're not willing to expose them to. Within your own brewery, that's a decision that you have to make when it comes to how you're going to segregate clean and sour beers with live microbes. Really important that any input to the filling process can be a risk of micro-contamination. The cans themselves, the rinse water, the CO2. So important that they are also tested on a regular basis for any micro-contamination. So how do we measure for microbial control? You can definitely do plating of beer, of swabs on lines, and get results a day or days later. But when it comes to filling, we like to have real-time feedback that a filler is or isn't clean. And the tool that we use for that is an ATP bioluminescence meter. ATP is present in all living cells. And if ATP is present in something, that typically means that there is a living cell there. ATP swabbing can't tell you what microbe or what living organism is present in something. It just tells you that something is there or isn't there. So we'll swab the surface that we're testing, and then the swab will go into a media that contains a bioluminescent material in it. And ATP combines with that to produce light. That swab is then put into a meter which detects the presence of light. And it's really a yes or no. Is there or isn't there micro contamination? It measures relative light units, so the more micro contamination there is, the higher that reading will be. But again, it really is all relative. There's no set number that says this is contaminated and need to clean, or this is okay and proceed. So we'll make sure that we're validating the effectiveness of our CIP by swabbing a surface that should be clean and compare the light reading on that to a threshold. And if the light reading is below the threshold, that means that it has none or an acceptable level of micro life. If it is above the threshold, that means that the reading is too high and we need to re-CIP or test what the swab is. Testing the inputs, we can do the same way using the swabs. We can either swab rinse water, use sterile water, bubble through CO2 from whatever source we're using and test that. And then read off of that swab if there's any micro contamination there. We'll make sure that the meter is using itself by doing a positive control. So operators will sometimes swab their hand or a surface they know is dirty and make sure that there's a reading off of that, because if a dirty surface is not giving a positive reading, that means there's a problem with the meter. Even if everything is working, really important to note that a negative reading doesn't guarantee that your system is clean. It tells you that there's no microbes present in whatever you swabbed, but that doesn't mean that there are microbes hiding somewhere, that there aren't microbes hiding somewhere else in the system. So part of the reason why we don't package any wild and sour beers is because there isn't really a way to guarantee that the entire system is clean. We can do our best with our CIP procedures, with our validation of that, but the fact is that there's always a risk because you can't swab the entirety of any beer contact surfaces in the system. Okay, last but not least, with respect to canning quality is seam control. Need to control seams because the seams are really what is keeping what's in the can in and what's out of the can out of the can. So we're making sure that product or CO2 are not leaking out of the can and that oxygen is not coming into the can. You can't sell cans that are leaking. That's just the reality. If you ship leaking cans, you can destroy a whole pallet of product, even if the rest of the product is good. If a retailer puts a leaking can on the shelf, that's something that a consumer can see before they even taste the beer. Whereas something oxidized is or potentially micro-contaminated, somebody could purchase that can and not know that there's a problem until after they've consumed it. Really important to note that seam specs are tied to the end or the lid, not necessarily to the can itself. The manufacturer of the ends that you're using will provide what the tooling requirements are. So what are the profiles of the chuck and the dies used by the seamer? And then what are the seam measurements and tolerances? So what should you be measuring and what should those measurements be to know that you have a good seam? Lots of breweries that we work with will purchase cans from us and ends either from us or another supplier. It's really not uncommon to see this, especially, co-packers will have one end that they run and might have customers sending them cans from all over. While can and flange profiles are somewhat industry standard, mixing and matching can lead to some risks. It's possible that the flange itself is thicker or less thick than the flange of the cans that the end manufacturer uses, which may throw off seam specs. It's also important to note that if there's a quality issue from the manufacturing side, it's going to be really tough to have any recourse with the manufacturer if the can is coming from one place and the end is coming from another place, because honestly, they'll just point fingers at each other, and the can manufacturer will say the end manufacturer's at fault. The end manufacturer will say the can manufacturer's at fault. There isn't a huge risk to this, especially if you're working with domestic supply, but there are definitely some differences on the market when it comes to cans and ends. How are we controlling seams? So making sure that you have the right equipment for the ends and cans that you're using. making sure that the tooling matches the end. Three main styles of ends that require different tooling that you'll see are the LOE or B64. This is the industry standard, and call it an older school product. It's definitely the most common, but there's newer end styles out there that actually save aluminum compared to the LOE B64. And those are the Super End, which is Crown proprietary, and then the CDL Plus, which is more of a universal version of a Super End, let's say. All three of these groups, the LOE B64, the Super End, and the CDL Plus, will have different specs, different tooling that's required. An LOE or a Super End could both go on the same can as long as they're the right size, but one filler and seamer can only handle either an LOE or a Super End, if that makes sense. For an end to fit on a can, the end size has to match the flange size on a can. So standard 12-ounce, 16-ounce cans are 202 end cans, so they need a 202 end. 200 ends will fit a slim can, the 8.4 ounce or 250 ml wine can will use those. 206 or a 209 end might be used on a 24 ounce can. With respect to controlling your seams, again, in the filling process, the engineering of the seamer itself is really important. The way that seamer is designed, how the chuck spins, how the dies come in to fold the seam on itself are really important. I've worked with fillers before that are pneumatic cylinders on the seamer operations, and they have a real tendency to fail. Any beer that splashes on, dries on, can start ripping through the seals, and then you don't get the same air pressure that you expect. So a cam-driven seamer is going to be much more consistent and reliable than a pneumatic seamer. When it comes to making sure seams are in control, maintenance is going to be key. Making sure that regular PMs are done on the seamer and the filler, making sure that it's clean and lubricated, inspected, and the tooling is replaced. Most seamer tooling will last for hundreds of thousands or even millions of cans, but there are going to be recommended intervals at which that tooling needs to be replaced. Wear on the tooling can be difficult to detect until you end up with a problem on your seams. Another way to control seams is through statistical control, measuring your seams over time and logging those measurements and seeing when things start to drift and being able to pick up drift before the seams come out of specification. So in terms of measurements, there's really two main ways that you can measure seams. One is manually using hand gauges, micrometers, calipers, and within the hand measurements, there's two different tests you can do. One would be a non-destructive quick test where you're just testing the outer measurements, the seam height and the seam thickness. The other would be a full teardown where you separate the can and the end after seaming and measure the internal components, the body hook, the cover hook, to understand what the overlap there is, and go from there. The other main way to test seams is through precision inspection, which would be a vision system with digital gauges. The vision system will be able to much more accurately and precisely measure the seam specs than manual gauges will. Manual readings are very dependent on the operator. The reading itself has a possibility of affecting the measurement. Too much pressure being applied by a micrometer will actually lead to a seam height or seam thickness reading lower than it actually is. But with a vision system, the way the can is cut into and then put into a high magnification camera will not affect the measurements that you're seeing from that seam. With respect to when we're measuring during the run, we'll do full teardowns at the very start of the run and then regular intervals. And again, at the end of the run, we'll do the kind of quick measurement, non-destructive measurement of the outer seam specs very frequently over the run, because that will be a good indicator that there is an issue. And then after the run, we'll actually bring cans back to our warehouse to put through our vision system, the precision inspection seam system, which will tell us if the cans at the end of the run were as good as the cans at the start of the run, but also help with that statistical analysis and measurement and see when seams start drifting so that we can make those adjustments before it happens. In terms of troubleshooting bad seams, really important to have the ability to take both the first operation and the finished seam measurement. So seamers will have two dies that come in. One will start the seam folding and the other will fully curl the end and the cover together, or sorry, the end and the can body together and press that seam in. Different issues can be a result of either the first op or the second op. So most seamers will have a mode to troubleshoot where it only uses the first op on the can. And then getting those first operation measurements as well as the full seam measurements will really help troubleshoot any of those issues. So in terms of mobile canning or canning in-house, just making sure that you're working with the appropriate vendors and partners with respect to equipment or services. At the bare minimum, anybody coming into your facility performing a service should have a full QA/QC program, should be documented and shared with you. You really want to get a report after each canning run that shows what the results of their quality checks were and also what the control limits are. Numbers on their own are pretty meaningless without understanding how they are relative to average or relative to appropriate control limits. Any mobile canner or anybody filling cans should have the ability to test the oxygen levels, potential micro-contamination, and seams. And also good to understand when you're talking to a mobile canner, what products do they fill, what products don't they fill? If you're buying a used piece of equipment, what product went into it or what was excluded from it? Ideally, any mobile canner, or if you're canning in-house, will have a Gehaltometer. The Pentair Hoffman's is what we use. Anton Par C-Box is an equivalent to that. Making sure that they have a bioluminescence meter. Precision seam inspection equipment. Again, we use one from a company called CMC Kunke, but there are definitely others on the market that are worth checking out. And then making sure that they're avoiding spoilers by not filling products such as kombucha, wild sour beers that could expose your beer to spoilers. Not every mobile canner, not every brewery will have the resources to be able to invest in this. The Gehaltometer, the seam inspection equipment, each of those could be as expensive as a new truck. And not every month, a brewery is able to make the decision on purchasing a piece of equipment that size. So, while that's not an investment that you can make in-house, good to work with a mobile canner who can. And then really when it comes into factoring in if you should or shouldn't invest in your own can line, the quality equipment definitely needs to factor into that decision. So in terms of setting up for success, any mobile canner should make sure that their operators are trained on the importance of quality and canning quality and filling procedures specifically, and make sure they have the ability to troubleshoot. So testing for a quality measure, be it oxygen, seams, micro, and understanding what to do in case of a failure. In terms of the equipment, like I said, it's quite expensive, either a Gehaltometer or a seam inspector, such as the Kunke. We like to try to help out our customers and offer seam inspections really on demand. If you're running cans, if you need some help troubleshooting, you want to see what the seam measurements are like, that's something that we can definitely help with. And I'm sure other can suppliers, mobile canners may be willing to help with that as well. So good to have a partner who is able to make that investment and help support you with it. So that is it for the presentation. Happy to take some questions. Haven't seen anything come in through the comments, but give it a minute. Otherwise, we'll sign off. All right. Well, thanks everyone for joining. It was great to have the opportunity to speak here. Big thanks to Andrew and Craft Beer Professionals for allowing us the opportunity. And if you have any questions on can supply, on canning, feel free to reach out to me. Vesselpackaging.com is our website, and my email is evan.singer@vesselpackaging.com. Thank you so much.